Okay, here we go. So we're going to do a little review. It's going to be mostly, I hope this doesn't freeze today, it froze literally 6 times in one period. So we'll see how this goes. But we're going to do a little review for the midterm here, and I'm going to give you just some things that you want to be aware of, basically, and we'll just leave it at that. How's that? So, first thing, we're going to need to know group names. Like 1, 2, 3 to 12, et cetera, 17, 18. Okay, know the group names for that. And I'm going to give you a pretty detailed list here. I'm not going to tell you all the answers. Okay, that's going to be up to you. You guys are going to have to do a little studying on your own here. But we're going to talk about group names. We're also going to talk about most reactive. Most reactive elements. Do you guys remember which ones are the most reactive elements? Reactivity increases or decreases. Which ones are the most reactive? What group is the most reactive? 17 and what? And I'll leave you with that then. Group 17, and there's another group. And what do you know about reactivity? Look it up. All right. Make sure you know which ones are the most reactive elements. Okay. And again, it's most important. Well, that's in your notes there. I know that is. If you look under group 1, group 2, group 3 to 12, 17, 18, it's in there. Look there. Okay. If you want to make a little note for yourself, do that. Let's see here. Next, you're going to have to know formulas and names of ionic and molecular compounds. Okay, formula and names. So be able to basically figure out what's the correct formula, okay, or what's the correct name of this compound. Okay. There's maybe about 6 questions on that, so don't screw that up. Okay, out of 45-ish. Okay, good? Okay. I guess make sure you know charges on elements when required. And what I mean by that is make sure you know that, for example, obviously, if you want to talk about ionic compounds, we use charges because charges are swap and drop, yes. If it's calcium, it's a 2+. It says that on the periodic table. If it's F, it's a 1-, yes. If it's O, that's a 2-. So you need to know that because periodic tables I give you don't have that on there, yes? Okay? So N is a 3-, et cetera, right? You guys probably wrote them in, but on my periodic table, that's probably not there. So make sure you know the charges on elements, okay? All right, what's next? Oh, yes. Protons, electrons, and the jimmies. Make sure you know how many protons, electrons, neutrons are in atoms, okay? In fact, I'm going to put this in atoms and in ions. Okay? How many protons, electrons, neutrons are there in an atom? How many protons, electrons, neutrons are there in an ion? Okay? What's the difference between those two statements there? You tell me. What's the atom? What's going to happen in the atom? Yep. They're not all the same. What's going to happen in an atom? Come on, somebody. Something is going to happen. Sure. These two add up to the mass. That'll happen in atoms or ions, actually. What else?
Only relating it to ions when they're not charged, so are they sharing electrons?
No. Yeah. No. the difference between these two, atoms and ions? What's an atom? Yeah. I can't hear you. For which one? Yes. So what? Tell me something about atoms then. So in an atom, these two have to be the same, yes? Atoms are neutral, yes? So if I had, for example, I don't know, let's pick nitrogen, because I think I know that one. Nitrogen is 7 protons, 7 electrons, yes? In an atom, nitrogen atom, yes? 7 protons, 7 electrons. It's atomic number 7, 7 protons, 7 electrons. In an ion, okay, ions are atoms with a charge. How does it get the charge? It gains electrons in this case, yes? In fact, 3 of them. So we'd have 7 protons and 10 electrons, yes? 7 protons, 10 electrons. That's how we get, look, 7 protons, 10 electrons. What's the overall charge? -3, yes? Right? Okay. Correct? 7 positives, 10 negatives, get a calculator. Okay. Now the neutrons, again, that depends on the atom. I can't say. In this particular case, just by fluke, we'd have 7 neutrons here because these two have to add up to 14.01 or 14, basically, yes? Okay, that's the atomic mass. Now, again, it depends on the atom that you're looking at, yes? I mean, once you get to, like, for example, I don't know, chlorine 17 protons, 18 neutrons, 35, right? So they don't necessarily match up. This is just kind of a fluke thing, right? For the atom as well, if we were talking about the atom, it'd be 7 protons, 7 electrons, and 7 neutrons, actually, in this case, just by fluke. Okay? All right, what's next? Okay, again, make sure you know which charges you have. Make sure you know electron dot diagrams. Otherwise known as Lewis, yes, diagrams. Make sure you know those. So be able to, if I said, hey, let's draw some, I don't know, let's do sodium. Sodium would look like that, yes? 1 dot for 1 valence electron, yes? And then we count over left to right usually, and that's how we're going to figure out how many dots we need to put there. Be able to draw some molecules. It's all multiple choice. Draw molecules. I'll put in here molecular. I'm not sure if I gave you ionic ones, but we should know how to draw those two, molecular and ionic. And of course, regardless of which one you're doing, what's the goal? Why do elements combine together? Why do elements combine? Yeah. To form octets, to become more stable, right? To help each other out become more stable. So you always want to make sure that you have 8 electrons where you need to have them. One of the exceptions is boron, yes? Hydrogen, I guess, 2 as well, so just keep that in mind. But we always want to make sure we have octets, okay? Whether that's ionic, we're going to show arrows, remember? Arrows moving, okay? And then this molecular, you're going to see lines for sharing, yeah? Yeah, okay? So just keep that in mind, okay? Okay. Remember, you need to have octets. Okay. I guess that's another. I'll just put that in here because I think that's important enough. That comes through the drawings, of course, but octets. You want to make sure that you have octets there. Okay. Good. Okay. Yeah.
Are we going to use any of the other diagrams?
Like the Bohr diagram stuff.
Yeah.
Well, no, I don't think you need to worry about the Bohr diagram, but I guess you should. Yeah, there's a energy level diagram. I wouldn't worry about that one. That's probably the least common one. Bohr is probably more important. Yeah.
Do we need to know what the diagrams look like at the bottom?
We'll get to that. Okay. We also need to draw polyatomic ions. So we're going to draw a polyatomic ion. Maybe we should just do one for review here. polyatomic ion. I don't know. What's a polyatomic ion we want to draw? Nitrate. Nitrate. Which is NO3 minus. Remember with these ones, of course, we want to add up electrons. Again, it may come down to this, it may not, because remember, it's multiple choice. So ultimately, you could probably look at the diagrams and decide which one you think is best, looking for octets and specific shapes. But again, if you did want to draw it and you wanted to match it up, that would be fine. Little review on this, of course, this would be 5 valence electrons. 6, 6, and 6 is 18, and one more, yes? So that's a total of what, 24, I believe? 24 electrons. We talked about, regardless if you want to add up electrons or whatever the case, but we always start with the best bonding capacity in the middle, right? Draw a skeleton structure kind of thing, like so. Connect the outside atoms to the inside, if you remember, like that kind of thing, right? That's used up 6 valence electrons so far. I have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You used up all 24 electrons. Again, you want to make sure that we have an octet around everything. We do for the oxygens, because that's kind of the point of making octets there. And then we're going to move a pair in, yes? Okay? And whichever pair you want, yes? And we'd end up with something that probably all said and done. If you wanted to use, you know, lines instead, if you remember. Something like that. And then don't forget, you're going to have brackets and a -1 charge in this case. Something along that line. Okay? Okay, good. All right. We should know, unfortunately for you, we're going to need to know a couple of shapes here. So shapes such as, for example, examples include tetrahedral bent, tetrahedral, trigonal planar, and etc. Okay, and I'll just leave it at that. So there is 6 shapes, yes. Make sure you're able to pick out the correct shape. And you might have a couple questions on that. Yeah, okay. I don't know. Tetrahedral? Yeah, that's a tetrahedral. Obviously. Yeah, okay. We should be able to draw molecules that we maybe haven't seen before either. So, for example, I don't know how I can explain this to you without giving you whatever, but we just want to make sure we're able to think about, okay, if I combine different atoms together, I mean, I think there's a way to do this, but just remember, like, you know, Lewis diagrams are pretty important. So if I said, hey, we have a hydrogen, for example, that looks like that. Let's say an oxygen, right? And maybe a carbon, for example. You know, how are we going to combine these together? For example, if our formula is, I'll just say this. Let's say we call this A, B, and C. How could we combine these together? So what would a formula be that basically gives us an octet kind of thing? All right. So how would I combine these together? And the formula might be like, I don't know, A, B2, or no, A, C, B2A or something like that, or whatever, and maybe what's the correct drawing of these ones kind of thing. So how are we going to put these together, basically, okay? Yeah, I don't know if that makes sense or not, but I'll just leave it at that, okay? We do have to be able to draw a few molecules, and you also might have to pick out basically how many single bonds, how many double bonds, how many triple bonds are in this, okay? So like A, B, C, D kind of thing options would be like, it's got 1 single, 1 double, and 1 triple, or it's got 2 singles, 1 double, and a triple, or something, I don't know, whatever, okay? You will have to know strengths of intermolecular forces, and I'll tell you what we're talking about there. Strengths of intermolecular forces. Who does know what the strengths of what am I referring to here? Yeah.
London, bipolar,
Yes. And with that whole thing as well, those are probably the most common ones, right? Which one's the strongest? Of course, it's what? Hydrogen bonding, and the weakest is London. And above those, of course, ionic metallic, yes? Okay, so let's not forget about those either. But again, we will have to think about boiling points and melting points. Okay, and now this is multiple choice, so again, we could have an arrangement for you, so lowest to highest, kind of like what we did on this test, if you remember. Organize these molecules lowest to highest. Now, they'd be organized for you already. You'd have to pick A, B, C, or D, or maybe just which one's the highest, which one's the lowest kind of thing. Okay, so if you're looking for the highest, you're looking for ionic metallic, if there is an option there, or hydrogen bonding. If you're looking for the lowest, you'd be looking for London forces and probably a small size or small shape, yes, or linear shape, or sorry, spherical shape, I guess, would be the lowest. Yeah, something like that. Okay. We have to know about polar, nonpolar. So be able to pick out molecules that are polar or nonpolar. Basically, which ones are polar, which ones are nonpolar. And that, I believe, would take care of Unit 1. Okay? Good? Okay. It's about, that'll take us up to about question, that's about 25 questions out of 45-ish. Okay? The other 20 questions, of course, will be Unit 2 stuff. Not quite as many there, but just because it's a smaller unit, and there's only so many ways I can ask you P1, B1, T1, and P2, B2, T2 kind of thing. Okay? But in Unit 2 here, we'll talk about that. Let's see. Unit 2 would be things like, molar mass. Be able to calculate the molar mass of a compound, of course. You're going to have to know the formula there for that. Be able to calculate moles, just moles. Okay. Be able to calculate molecules from moles. Or, molecules from moles, I guess. That's why you have to know moles to know molecules. Vice versa, molecules gives you moles. Okay, so be able to do those things. Next, I would say, I don't know if there's a specific order for this because they're kind of mixed up here a little bit, but let's go with this. Let's go with gas laws, I guess you'd have to know. And I believe there's 5 of them. Okay? 5 gas laws at the beginning of the unit there. That wasn't on our test, I don't think. In a roundabout way it was, but there's 5 gas laws from Unit 2, lesson 2, I think. There's 5 gas laws. Look them up.
Do you mean like the properties of the gas?
Properties of a gas, yeah. Properties of a gas, yeah. Sorry, 5, I'll put that. Gas laws, properties. Let's go with that. Like, for example, gases always take on the shape of their container, that kind of thing, right? That thing there. Okay? Sorry, thank you. Combined gas law, of course. I'm just going to put combined gas law, which could include Boyle's, Charles, Gay-Lussac's, yes. So I'm just going to put 3 here. But Boyle's law, Charles' law, Gay-Lussac's law, obviously would be part of that, yes. You know, if the temperature's staying the same, then get rid of it, and now you're dealing with Boyle's law, yeah? Okay? So that's all I'm going to say about that. Oh, okay, good. Real gas versus ideal gas. I'll just say this. It's a pretty similar question to Unit 2 test. We'll just leave it at that. Real gas versus ideal gas. What else? Remember, also, with this, if we're going to double the volume or triple the temperature or whatever the case might be, how do we do that? How do we do that? If I'm going to double the volume, triple the temperature, whatever kind of thing, you had a question like that. I told you, right? If the volume, what happens to the volume if the volume wants to double, what happens to the temperature? It has to double, right? So there has to be those relationships that you understand. If you're not sure, you make up numbers, yes, kind of thing. So you might get some of those. I'm just going to put double, triple pressure or volume or temperature. Okay, so you might have to double the volume or triple the pressure or something. I don't know what happens to the temperature, et cetera, et cetera. Okay, so again, make sure you you can make up some numbers there. Okay, let's see. Then the rest is, let's see. I guess this would be what? I guess there's a molar volume question. Molar volume, you'd want to know. I'm actually going to let's talk about the notes portion. So there's a molar volume question which kind of refers to the notes, I guess. We'll just leave it at that, I think. Okay. There's going to be a lot of, I don't know about a lot, but ideal gas law. Please, if you haven't jumped on board with the right units yet, please do so. Okay. Otherwise, some of these answers aren't going to make sense for you here. Okay, ideal gas law. And, yeah, there's another one of those questions. And there's a Dalton's law partial pressure question. And that's all I'm saying about that. Okay. And there's going to be a few that are kind of mixed up here. It's somewhat in order, like the Unit 1 questions are all Unit 1 and 2, and they kind of go in that order, okay? But there's going to be a little bit where you're jumping back and forth. So just so you know, once you get to ideal gas law, don't think that we're done with combined gas law, basically, is what I'm trying to say. Because there's going to be a little bit back and forth and so on. Okay? And that's pretty much it. Okay? 45 questions, multiple guess, or hopefully choice. Let's go with that. And yeah. Okay. The only thing is I will say this. I'm going to actually record this, I think. Again, on Monday, if you think you're going to need a little extra time, try and get here a little bit. I guess you can't stay early. Never mind. You guys are period 2, not period 1. If you need a little extra time, you're going to have to probably stay until lunch, okay? You might, just because it's 45 questions, some of them are going to be like a second, okay? And you probably should know the right answer. Some are going to be some calculation stuff, so it's going to take longer. So you just got that back and forth thing, okay? And I get that. So the calculations might just take a little long. Like, not that they're more complicated, it just might take some time to write them out, solve for the right variable, and all that stuff. It's going to take time, okay? And you're going to have, you know, about I shouldn't say this. You're going to have some calculations to do. That's what I'm trying to say. So, and you got to draw molecules out and things like that. So that's going to take some time as well, okay? And if you're not sure exactly, then again, you know, look at the multiple choice options and say, okay, well, maybe this is, what if I did it with these ones? You know, is that going to work out? Or if I look at this, try this one. You might have to go through all 4 options and then decide if you're kind of struggling a little bit with what the question is doing. You might have to look at the 4 options and say, okay, let's try with this, let's try with this, let's try with this, let's try with this, and then go on that. I mean, if you know, it shouldn't be that issue, but you know, that's a strategy that you can try in case you're not sure exactly. I mean, go through the 4 options and see if any of those are going to work for you. Yeah.
This is on
Monday,
Monday.
yeah. Okay. And again, you might have to go into lunch a little bit here. Okay. Good. Questions, anyone? All right. I think that'll be it for today then.